guys, so we're going to start unit number 5 from our book, which is forces and their applications. So the first thing that I would like you to do is to start by reading the first 2 pages of the unit, which are 132 and 133, and make a summary of them as homework, okay? And now what I'm going to do is to display the contents, which are explained on page 134. So we're talking about forces, okay? We already learned something about forces in segundo de eso, so this is no news for you, okay? What I'm going to explain here is basically what you did already in segundo de eso, okay? So we're talking about forces, which are vector magnitudes, so they have a magnitude and a direction. That means that not only the intensity of the force applied is important, but also the direction, which might be south, north, east, and so on, okay? So basically, what I'm going to explain, as I said, is on page 134, and it's basically what we call the composition of forces. So I'm going to write it here, composition of forces, okay? So what does composition mean? It basically means the total force that is obtained by having several forces present, okay? So, obtaining the total force equivalent to several forces. So we're going to have more than one force acting at the same time on one object, and we're going to see the effect that this is creating on the object where the forces are being applied, okay? So if you take on page 134, we have several pictures in order to understand this, which are talking to us about different situations. So we might start by talking about the first situation, which is basically concurrent forces, which is the point 2.1 in our book, okay? So I'm going to erase this, and we're going to learn about the composition when we have concurrent forces, okay? So I'm going to write it in here, concurrent forces, as opposed to parallel forces, which appears on the other page. We are not going to learn about parallel forces, we're only going to learn about concurrent forces. So for concurrent forces, we have 3 cases, okay? So case number 1, situation number 1. It would be, for example, 2 people, as you can see in your book, you have this picture. So 2 people are pushing the box, and each person is pushing with a different strength. We will see, for example, this is force 1, which is applied by person number 1, and force 2, which is applied by person number 2, okay? Let's say that, for example, for 1 is 5 Newton and for 2 is 3 Newton, as an example, okay? They're both pushing in the same direction. So this is equivalent to this situation. We still have the 2 people, and instead of having 2 different forces, we're just going to have one force, which is called the net force. Okay? Net force. So the net force is equivalent to all of the forces that are acting on the object together, okay? Remember from last year, we already know about this, that force is measured in newtons after Isaac Newton, okay? So the net force in this case, because both people are pushing in the same direction, would be the addition of 2 forces. So it would be force 1 plus force 2. In this case, for example, we would have 5 Newton plus 3 Newton. We would have 8 Newton in this example, okay? So they are pushing in the same direction, okay? Now let's go to case 2, the second case. You also have it in your book, so you can follow it easily. And also we did this in segundo de eso, if you remember the exams from last year, okay? We already did this in our examinations. So in the second case, we're going to have one person pushing from each side, okay? So one person is going to be here, the other person is going to be here, and we're going to have, for example, this force 1, and we're going to have this force 2, okay? We're going to do the same. So force 1 is going to be 5 Newton, and force 2 is going to be 3 Newton, for example, okay? Okay, so what we have in this time is two people are pushing something in opposite directions. So this means that one of them is kind of fighting the other, so they are going one against the other. So the person who is going to win is the person who is pushing with a higher force. Okay, so that would make sense. And we would have a net force which is kind of smaller than this because this is subtracting part of this, right? So the equivalent force, the net force, would be smaller, but in the direction of the bigger force, okay? So how do we calculate the net force in this second situation? I'm gonna do it here. So the net force is going to be the bigger force minus the smaller force, okay? So always, this if F1 is always bigger than F2, okay? Or they might be the same. They can also be the same. Okay, so the total force or net force would be, in this case, 5 minus 3 Newton. This would be 2 Newton. And in which direction? Direction of the bigger force, okay? So the net force goes in the direction of the higher force, okay? So in this case, the person pushing with the higher force is the one who wins. Let's say it like that. What would happen if F1 and F2 were the same? If this were 5 Newton and this were 5 Newton, well, 5 minus 5 equals 0, okay? I'm going to write it here. So, what happens if F1 equals F2, okay? For example, 5 Newton and 5 Newton. What would happen? So think about it. We're pushing 5 Newton from one side, 5 Newton to the other side. So net force equals 5 Newton minus 5 Newton. So 5 minus 5 is 0, okay? So this would mean no effects. If you do the summary on pages 132 and 133, you will realize that forces create effects on bodies. For example, motion. This is one of the effects. So in this case, if this is higher than this, it would create a motion towards that direction, okay? But if they have the same intensity, then the net force would be 0, okay? This is just another example. And now we're gonna do the third one. So the third one is going to be when forces are not parallel. So we're still pushing the box. Imagine that we're looking at this from the ceiling, okay? So we have one person pushing in this direction, okay? We're gonna call this force 1, and another person pushing in this direction, force 2. Look at the book, please. Look at the book because the picture is much better than mine, okay? So this has an equivalent situation. This person, for example, wants to push the table towards the window, and this person wants to push the table towards the door, okay? And the table would kind of move somewhere in between. It would move like in that direction, okay? We'll see this. So the equivalent would be, I'm gonna draw the forces in the center of the table. So let's say this is F1 and this is F2, okay? And what they do together is that they add and they create a net force going in this direction, okay? So motion would go kind of in the diagonal, okay? How do we calculate this? So you should remember from the previous unit that we have to use Pythagoras theorem, okay? So we have to use Pythagoras theorem. Remember, from unit number 4, we were studying that already, okay? So let's calculate it in here. So the net force equals to the square root. This is the hypotenuse in a rectangle triangle, okay? And these are the other two sides. So force number 1 square plus force number 2 square, okay? This is very important. You know that you're allowed to use a calculator at all times, okay? And you have, you know, the value of both sides. So let's set an example. So example, force number 1, 5 Newton, force number 2, 3 Newton, okay? So we're gonna do this here. So the net force for our example would be square root 5 square plus 3 square, okay? So we calculate the result. So it would be 25 plus 9 square root 5.8 Newton for our example, okay? Sorry, not a lot of space. 5.8 Newton, okay? So this is the value of the net force. So what things do you need to know in order to start this unit? You need to know how to draw this. So you need to know how to make the picture. You need to know that forces are measured in Newton, okay? You need to know how to calculate the net force for these 3 different situations, okay? So now what we're going to do is I'm going to solve, as an example, problems number 7 and 8 on this same page, okay? So as an example, I'm going to be doing exercises number 7 and 8, okay? So we're gonna start by doing number 7, okay? Remember that we're talking about page 134, okay? So it gives me a picture on the right. I'm going to copy the picture on the right. They give me a box and they give me several forces acting on it. So I'm going to draw them. So they give me, for example, here a force to the right, which they call force number 2, 4 Newton, and in here force number 4, 1.5 Newton, force 1, 3 Newton, force 5, 1.5 Newton, and force 3, 1.5 Newton, okay? And they are asking us to calculate the net force in the system. So resultant force is the same as net force, okay? Resultant force is the same as net force. And it is also the same as total force. Okay? They are all the same way of calling something, which is the absolute calculation of this, okay? So as you see, there are forces in this direction and forces in this direction, okay? So we're going to start by doing the easy part. So the easy part is working with the axis. So I'm going to call this the x-axis, okay? And I'm going to call this the y-axis. And I'm going to calculate first on the x-axis, and we're going to do the calculations in here. So we're going to do is F2 goes to the right. So going to the right is going to mean positive, okay? And going to the left is going to mean negative, okay? So we're going to do on the x-axis F2 plus F4 minus F3. Can you see this? Because F2 and F4, they're both going to the right, but F3 is going to the left. So it will mean that F3 goes against these two forces, okay? So we're going to replace our data and we're going to do, okay, force number 2 is 4 Newton plus 1.5 Newton, okay? So these two forces, 2 and 4, they go to the right. And then I subtract, okay, I subtract 1.5 Newton, which is force number 3, okay? So I get a total solution. 1.5 minus 1.5, they leave, so I have 4 Newton, okay? I'm gonna call this Fx because it's on the x-axis, okay? This means that I can replace these three forces by only one. So I'm going to erase this one. I'm going to erase force number 3. I'm going to erase force number 4. And I'm just going to leave this, which is 4 Newton. Instead of 2, I'm going to call it force x, okay? So the three initial forces can be replaced by just one force, okay? Because I do this calculation and I obtain 4 Newton, okay? So this is the first calculation on the x-axis, okay? Now I'm going to do the same, but working on the y-axis. So I'm going to do total force or net force on the y-axis. It's going to be, and I'm going to use the directions. So I'm going to say that going upwards is going to be positive and going downwards is going to be negative, okay? So F1 would be positive minus F5, okay? You see that? F1 is going upwards, F5 is going downwards, they go against each other. Now I replace my numbers, so F1 is going to be 3 Newton, and I subtract 1.5 Newton, okay? So the solution 3 minus 1.5 is going to be 1.5. Pointing in which direction? The direction of the higher force. So 3 is bigger than 1.5, which means that the solution is going to be a force pointing upwards. So I'm going to erase this, okay? And I'm going to erase this. And what I'm going to do is going to draw this force, the equivalent force, which is Fy, and Fy is 1.5 Newton. Okay? So this is basically it, okay? So all of the initial system that I had at the beginning is reduced to this much easier system. And now I can erase all of this. And the only thing that I have to do is calculating the total force with these two forces. So remember that these forces are not parallel. So what I'm going to do is I'm going to add them by using Pythagoras theorem, okay? So this is Fx is 4 Newton, okay? So what I'm going to do is, okay, so the net force is the square root of Fx squared plus Fy squared, okay? So I calculate it and I say, okay, this is 4 squared and this is 1.5 squared, okay? So this square plus this square, like we did in the previous unit. So I'm going to calculate it. Okay, 1.5 squared. And this gives me 4.27. So this tells me that the net force is 4.27 Newton. Never forget the units, okay? Units are always really important in physics and chemistry. And this is the total solution. This means that the total intensity of this force is 4.27 Newton. It is very important to do the picture. The picture is equally important than the calculations, okay? Never underestimate the importance a picture has in physics and chemistry, okay? Okay, now that I'm done with this exercise, I'm going to do exercise number 8. So let's go with it. Okay, so we go with exercise number 8, again on page 134, do not forget. And they tell me a boatman exercises a force of 10 Newton to the east. So 10 Newton to the east. This is a force that the boatman is exercising, okay? I'm going to do here the directions, the geographical directions. Okay, you don't need to do it as fashionable. So this is basically north, south, east, and west. Okay? And they tell me that the current exercises a force of 6 Newton to the north. So there's 6 Newton to the north. Okay. So I'm gonna call this force 1 and this force 2. Okay? So they tell me what is the resultant force of the boat. Draw a sketch of the forces acting on the boat. Okay? So I need to draw a sketch. So the boat is going to be, well, what a terrible boat. It's going to be kind of this. Okay? And then, so, okay, no, sorry, going in the other direction. If we look at it from upwards, so the force that the boatman is exerting is 10 Newton to the east. So we're going to draw this is going to be force 1. But the current is pushing, and the current is pushing to the north. So this is going to be force 2. Okay, force 1 is bigger than force 2 because force 1 is 10 and force 2 is only 6. So this should be bigger than this, okay? We see the situation and we say, okay, so the total force is going to be something like this, okay? This is what we call the net force, resultant force, or total force. So let's go and calculate it. So we have to use Pythagoras theorem. So net force is going to be the square root of force 1 square plus force 2 square, okay? So it's going to be the square root of 10 square plus 6 square, okay? So let's do the solution. So square root of 10 square plus 6 square, so this is equal to 11.66 Newton. Never forget the units, okay? So this is basically the total force acting on the boat, and it is neither going east nor going north. It is going somewhere in the middle, okay? So that would make sense. Okay, guys, I hope you could follow the problem. See you in the next video.